Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. I hope you have attempted wholeheartedly today's exam. Well, this session is there for you so that you get some extra help in solving questions from your exam after you're finished with the exam. In this session, I'm going to discuss about the possible solutions and answers of the chemistry part of the NEET practice exam which was conducted today. Now let us have a look at the first question. This question states that which of the following is correct about group 15 elements? Whenever you see this group number 15, all the elements should line up in your mind's map, right? So group 15 are, let me take the nitrogen, phosphorus, arsenic, antimony and bismuth, right? Now here nitrogen and phosphorus are non-metals, right? These are metalloids and bismuth is a metal. So I think this is about that. So nitrogen and phosphorus. Nitrogen and phosphorus are metals? No, totally false. Arsenic and bismuth are metals? No, one is metalloid and the other one is metal. Antimony and arsenic are metalloids? Well, that appears to be correct. That is true. Phosphorus and bismuth are non-metals? No, phosphorus is non-metal, but bismuth is a metal. So this is false. So the only correct answer for this question is not 2, third, right? Because that is true. Moving on to the next question. Which of the following properties of group 15 irregular trends observed? Means in which of the property there is no regular decrease or increase? Well, the answer for this is supposed to be the melting point. That is because, understand this very carefully, that nitrogen exists as a single molecule, whereas other things like phosphorus, right, can exist as a tetramer. So here there is less bonding, here intramolecular bonding is more, it is covalent, so melting points are a little higher, due to which there is an abnormal behavior. Moving on. Which of the following will not show allotropy? Now, allotropy, we know that it is the existence of more than one form of a particular element. Now, in that one, the first thing which is decided here is that all of them, phosphorus, arsenic and antimony, can form different allotropes. Why? Because multiple bonding is not possible in any of them. Multiple bonding is only possible in nitrogen. So nitrogen's one form is so stable that it does not need to form different allotropes, right? We remember the nitrogen, triple bond nitrogen is one of the strongest bonds known in nature. So it is only nitrogen that does not show allotropy. Moving on. The set of atomic numbers belong to group 15. Now for this we have a short trick, right? We know that here you have helium, with this we have certain numbers associated, right? 8, 8, 18, 18, 32, 30. Right? Now, group 15's nitrogen comes in the second period. So nitrogen lies somewhere here and nitrogen's atomic number is 7. Right? Now, if you add 8 in 7, what you are bound to get? You are bound to get 50. And then you add 18 in 15. So what you are bound to get? You are bound to get a number called 33. Then you add 18 in 33. You're bound to get a number 51. And then in 51, if you add 32, you are bound to get 83. So in this way, you have to solve questions where atomic number is asked, right? So you can see these are the numbers which are matching: 33, 51, and 83. So fourth is the correct answer for this. Moving on, the common oxidation states of group 15. Now group 15's configuration is NS2NP. So it can gain 3 electrons, right? So plus 3, definitely, sorry, minus 3. Minus 3 is possible, right? It can lose these, so plus 3 is possible. And it can lose complete 5 electrons, so plus 5 is also possible. So plus 3, minus 3, and plus 5. So all of these oxidation states are possible. Why minus 3? Because if minus 3 means it accepts 3 electrons, so this becomes NP6 fully filled, or it can lose these 3 electrons, right? Then again it is fully filled, or it can lose these 5 electrons completely, then also it is fully filled. So that's why these 3 configurations or oxidation states are valid. Which of the following is not correct? Remember, we have to see something which is not correct. Don't be fooled by this. They try to mislead you. Normally, as a normal thought process, we think that we are going to answer that is correct, but they're asking you the thing which is not correct. So in these kind of questions, your basic memorization power is tested, right? So ionization enthalpy of group 15 is much greater than group 14 elements in the corresponding periods. Yes, because as you move from 15 to 14, what happens? 14 to 15, what happens? The electronegativity is increasing. As electronegativity increases, attraction for electron increases, right? So instead of, removing electron will become more difficult. So yes, this appears to be true. Bismuth forms metallic bonds. Yes, because bismuth is a metal. So true. The catenation tendency is stronger in nitrogen. Well, this appears to be something not correct, because see, catenation tendency depends upon the single bond between the elements. So if you talk about the bond energies, so nitrogen, and then you compare phosphorus, nitrogen has lone pairs, and those lone pairs repel each other, decreasing the N single bond N bond energy. So if I talk about bond energy or bond dissociation energy, that is higher for phosphorus. So phosphorus bond is stronger. And as a matter of fact, catenation tendency is in this order, and then you have your nitrogen, right? So phosphorus has more catenation tendency than this. So this appears to be the false answer, or in our case, the correct answer. This is also correct. Maximum covalency of nitrogen is 4. Match the following. Nitrogen forms p-pi bonds. Yes, we know that, but let us match it to why it forms. This is because small size of nitrogen and high electronegativity. So P matches with D. We can say that it matches with D. Q. Single NN bond is weaker than single PP bond. Just I discussed, because of higher interionic repulsions of non-bonding electrons, right? Right? Because you can see non-bonding electrons are getting repelled, due to which it is happening. So this matches with C. Stability of +5 oxidation state decreases and +3 increases down the group. Why? Because of inert pair effect. Remember, you have NS2NP3 here, right? Now in this NS2NP3, what happens is, as you go down the group, the D and F orbitals are involved. These D and F orbitals are poor shielders of nuclear charge. So nuclear charge is felt more by these two electrons and they resist getting lost. So they become inert. And as they become inert, they cannot be lost. Understand that +5 oxidation state is only possible when these get lost. So because their loss is difficult, the +5 oxidation state stability also decreases due to inert pair effect. So this matches with B. The covalent radius increases from nitrogen to phosphorus. Covalent radius, remember. But arsenic and to bismuth only small increase. Why? Again, when you go from arsenic to bismuth, you have F and D orbitals involved, which are poor shielders of nuclear charge. So they shrink the outermost valence shell and thus decrease the size. So this is because of completely filled DNF orbitals in the heavier metals. So A. So answer should be DCBA. So you have DCBA. Third is the correct answer. Moving on. Which of the following is correct in case of nitrogen? In case of nitrogen, this is purely memory based, right? So in this one, I'll directly go to the answer. All oxidation states from +1 to +4 tend to disproportionate in acidic medium, right? Purely memory based. If you have memorized it, if you have revised it, then you can give an answer to this. Which statement is or are correct for halides of group 15? Halides. Bismuth can form Bi5. I don't think so, because bismuth going down the groove, what is happening? Your inert pair effect is increasing, right? This inert pair effect does what? It decreases the possibility of +5 oxidation state forming, and here bismuth is in +5 and it is lying at the bottom of the groove, right? So this appears to be false. Pentahalides are are more ionic than trihalides. Think about it. According to Fajan's rule, remember, so you have pentahalides. So suppose you have an element pentahalide and you have trihalide. In pentahalide, the oxidation state is +3, here +5, here +3. Remember in Fajan's rule, it says that if you have an ionic compound where the cation has large positive charge density or high positive charge, then the amount of covalent character will be more because the cation will have high polarizing power. So here it is more covalent and this is more ionic according to Fajan's rule. So does this? No, this appears to be false. Opposite is true. All trihalides except nitrogen are stable. This appears to be true. BIF3 is covalent in nature. I think this is supposed to be BIF3, right? Then only it can be true. +5 it does not form. Now, stability of BIF3 is covalent in nature. No. Stability order of these halides. Is this correct? Well, understand that nitrogen belongs to the second period, right? And these are formed by overlapping of orbitals, second period. So for nitrogen, N is equals to 2. In NF3, fluorine also has an orbital in which N is equals to 2. So for nitrogen also N equals to 2, fluorine also N equals to 2. So what happens is the overlapping orbitals now have similar energies. And remember, according to valence bond theory of hybridization, that if the overlapping orbitals have similar or same energy, then the extent of overlap will be more and bonds will be much stronger. So bonds are highly strong in NF3, and as you move down, what is happening is N becomes equals to 3 here, N becomes equals to 4, and N finally becomes equals to 5. So as you move towards this, the energy difference between the overlapping orbitals increases. So the bond becomes more and more weak, right? So this also appears to be true. So P, R and T are true. Moving on. The large difference between melting and boiling points of oxygen and sulfur may be explained on the basis of simply atomicity, because oxygen forms O2 and O3, but sulfur can form S8. So if you try to melt it, then sulfur breaks up into individual S atoms, and here you are breaking up what? You're breaking up weak van der Waals forces. So breaking up weak van der Waals forces. Here on the other hand, you're breaking up covalent bonds. So yes, it has a higher melting point. So atomicity does explain this. Moving on. Which element of group 16 does not show -2 oxidation state? So we have moved forward to group 16. So we have moved forward to NS2NP4. -2 means that it does not want to gain electrons, it wants to lose. Remember, as you go down the group, what is happening? Your electronegativity is decreasing. Right? Also, your electron affinity decreases. Attraction for electron decreases. So -2 oxidation state, attraction for electrons is minimum in polonium, and -2 is achieved when you gain 2 electrons. So that gaining will be difficult most in polonium. So polonium, if it is there here, will be the correct answer. Moving on. The correct order of electron affinity of group 16 elements. Now let us go on to the order. So now, normally what should happen is, if you have, as you're going down the group, the n shell is increasing, right? This is n equals to 2, this is n equals to 3, 4, 5 and 6, so on and so forth. As the distance from the nucleus of the valence shell increases, the attraction for the electron should decrease. So electron affinity should decrease. So the order should have been oxygen maximum, sulfur, selenium, tellurium, and then at the end you should have polonium. But oxygen, because it is small sized, because there are electron-electron repulsions, its electron affinity decreases. How much does it decrease? It decreases in the entire range. So this oxygen moves from here to here, and the order now becomes, right, sulfur, selenium, tellurium, polonium and O. Right. So moving on, which of the following is not correctly matched? Now again, this is a memory based question. So this memory based questions you can ace only when you keep on revising that material which has been dealt with in the class, right? So here, this is the correct answer. This is not correctly matched because in reality this is a gas, right? Moving on. Oxygen and sulfur both are members of the same group. Yes, they are in the periodic table, but H2O is liquid while H2S is gas. The only reason and the most famous reason for everything and anything anomalous about water is that water can form hydrogen bonds, right? So this kind of a hydrogen bonding is possible in water, due to which intermolecular forces of attraction are strong here. And because they are strong here, this exists as a liquid, and H2S is a rotten egg smelling gas. Remember, in salt analysis, you have learned that H2O is a rotten egg smelling gas. Which a rotten egg smell. It has a rotten egg smell. So simple, water has weak hydrogen bonds between them. Not weak, it is actually very strong. But okay, this is the most probable answer. Electronegativity of oxygen is more than sulfur. Yes, it is true. Yet H2S is acidic while water is neutral. Why is it so? Because H2O is a covalent compound. If it was an ionic compound, well, things would have been different. In a covalent compound, the bond strength depends upon the difference in the energies of the overlapping orbitals, right? So if the overlapping orbitals are of similar energy, then the overlap is better and the bond is strong. But if the energy difference is large, as you keep on increasing the energy difference, the bond strength keeps on decreasing, right? So HS bond is weaker. Why is it weaker? Because this is a 1s orbital that is overlapping with hybrid orbitals or non-hybrid orbitals. That is a debate for another time. But n is equals to 2, n equals to 1 for hydrogen here. But for sulfur, what is n? N is equals to 3. You can see energy difference is large. But in HO, this is n equals to 1 and here n is equals to 2. So energy difference is little less. So this bond is stronger. So water, if you see, is neutral, but H2S is slightly acidic. Right? So fourth is the correct answer. Moving on. Amongst these, one having the higher boiling point. No guesses here. I told you that H2O, because of hydrogen bonding, the force of attraction between one molecule of H2O with another molecule of H2O is strong. So it is difficult to pull them apart into gas phase where boiling occurs. So H2O because of hydrogen bonding. Moving on. Which of the following hydride of group 16 will not possess reducing property? First, you should know how do these hydrides act as reducing agents. These are hydrides for that matter. Hydrides mean if you have the element, they act as reducing agents by donating H minus. So more easier is this donation, better it is a reducing agent. Let us see where is this donation easy. Now this donation will be easy because when this bond is weak. So when your EH bond is weak, then what will happen? Donation of H minus is easy and reducing power is more, right? Is more. So let us see the weakest H bond. We know that the order of elements in the group is, so the lowest one lying but we want will not possess reducing property. So obviously we need strong EH bond so that this bond is not broken. So answer is 2 because the bond is very strong. Moving on. Which element of the following will exhibit inert pair effect? Inert pair effect I have already explained in a similar question previously. It depends upon the effective nuclear charge on the valence shell. Now this effective nuclear charge should actually decrease as we go down the group, but in the elements immediately following D and F block elements, what happens is, specifically in the 13th, 14th, 15th group, what happens is that this D and F block elements are poor shielders of nuclear charge, so they get an increased effective nuclear charge, due to which the S electrons become inert to being lost. That is the inert pair effect. So it will be maximum in the lowest element, which is polonium. Which of the following is not correct? Not correct. SO2 is a gas? Yes, it is. SeO2 is solid? Well, that is also true. All types of possible oxides of group 16 are acidic. Acidic means what? They can accept electrons or they can donate H plus. Yes, they are acidic. Little bit, but they are acidic. Reducing property of dioxide increases from this to this. Reducing properties of oxides I'm talking about. So reducing property means what? So if you have reducing property means itself it should be easily able to get oxidized, right? So it should be an easy oxidation or loss of electron should be easy, which depends upon electronegativity in short. So if you go from SO2 to TeO2, you're going down the group. As you go down the group, electronegativity actually decreases. Electronegativity, if decreases, then so SO2 is reducing while TiO2 is an oxidizing agent, right? So as you are going down the group, the ability to lose electron increases. So if you base it on this, then I don't think so you'll get a correct answer. Let us actually reducing property decreases from SO2 to TiO. This is the false answer and which is not correct. So third is the correct answer. SO2 is reducing. Even I don't think so. This SO2 is reducing while TeO2 is oxidizing agent. This is the correct answer, sorry. I think in the key it is wrong. Okay. Moving on. Which of the following is more stable? The most stable in this is this. Why? Because it has an octahedral geometry. Right? And fluorine sizes are small. Right? Because of the small size, they are able to arrange 6 fluorine atoms around a sulfur atom easily. But if you increase this size to chlorine, then they get steric repulsions and this destabilizes the compound. This is one thing. Second thing, this fluorine, blanket of fluorine prevents attack of any nucleophile like water on this, and that attack does not occur, right? Because of which SF6 is most stable. Moving on. Which elements of group 16 will show +4 and +6 oxidation states commonly? So you have understand that oxygen will mostly show -2, -1 and 0 oxidation states. +1 also we have seen. Now sulfur will show -2. I have seen it -2, -1, +2, +4 and +6. So these oxidation states will be shown by these 3 elements, and at the end you will have just +2 and 4. 6 will not be there because of the inert pair effect. So sulfur, selenium and tellurium will show these oxidation states commonly. Which of the following statement is not true for halogens? All form monobasic oxy acids. Well, this appears to be false. Actually, fluorine does form monobasic oxyacid, which is HOF, but it is not very stable. Why? Because fluorine is highly electronegative. It pulls electron density here, right? And you'll get 2 here. And then it attacks this, leaves this out. So you'll get HF plus oxygen. Right? You can balance this out like this. So it's forms, but it's unstable, right? So this is the correct answer. All are oxidizing agents. Yes, they can accept electrons. So all are oxidizing agents. This is true. Chlorine has the highest electron gain enthalpy. Yes, this is also true. But all but fluorine shows positive oxidation states. Yes, because fluorine is most electronegative, it will not lose electrons at any cost. And to show positive oxidation states, you need to lose electrons, right? Or be attached with electronegative elements. So fluorine is going to show only negative oxidation states, no positive oxidation states. Which of the following orders is correct for the bond dissociation enthalpy of halogen molecules? See, normally, as you go down the group, what is happening? The size of the orbitals is increasing. The distance between the nuclei is increasing. So, internuclear distance is increasing. So, normally, the bond dissociation enthalpy should be in what order? This should be the order. This should be. But it is actually no. Why? Because here, if I just remove this, fluorine has electron-electron repulsions. Because of these electron-electron repulsions, this bond becomes weak. And exactly how much weak? Well, just little bit. It moves from here to this position. So the order becomes Cl2, Br2, F2, and you have I2. Right? So second is the correct answer. Moving on. Electron gain enthalpy with negative sign of fluorine, with the negative sign of fluorine, is less than that of chlorine due to, just we discussed, smaller size of fluorine. Moving on. Which of the following is correct statement? Fluorine has higher dissociation energy than Cl2. No, this is false. Fluorine has higher electron affinity. No, it doesn't, because it is small sized. Electron-electron repulsions repel the incoming electron out. So this is false. HF is stronger acid than HCl. Well, I don't think so. Even that is true, because HF, I told you, the HF bond is stronger than HCl because of the similar energy orbitals overlap here, whereas there is large difference in orbitals which are overlapping here. This also is false. So we are left with fourth, right? Everything else is false. This will be the correct answer. Boiling point increases down the group in halogens. Why does that happen? Well, halogens basically are what? Halogens have XX bond, non-polar bonds. So when you have molecules where there are non-polar bonds, the only interaction possible are van der Waals forces of attraction. And in van der Waals also, the only force of attraction possible is London dispersion forces or dipole London dispersion forces, where a momentarily dipole is induced because of unsymmetrical distribution of electrons. And more is the electrons, right? So if electrons are more on this side, you will get a delta negative, delta positive, and this in turn will push electrons of the next molecule towards this side. You will get delta negative, delta positive, and this force of attraction is what drives its intermolecular forces. Now, this dispersion will be stronger if the number of electrons are more, and number of electrons are more when you have a high atomic number, right? And atomic number increases when you go down the group. So as you go down the group, atomic number increases, number of electrons increases. So boiling point, if I talk about, is directly proportional to number of electrons, directly proportional to atomic number, which is directly proportional to van der Waals forces of attraction. So that is why boiling point increases down the group. Moving on, this I have already done with. The correct order is HF bond strength is higher. Okay, they are asking about bond length. So bond length is not higher. We know that bond strength is inversely proportional to bond length. So bond length is actually inversely proportional. So this order is supposed to be in this way. So this is false. Now, let us talk about the melting point. HF has strong hydrogen bonding. So melting point will be higher for HF than HCl than HBr based on the strength of the hydrogen bond or also van der Waals forces of attraction. So but even here the correct order will not be this. The correct order, because of this hydrogen bond strength, normally the correct order should be HI should be higher than HCl, then HBr, and then you should have HF. But because of hydrogen bond, this comes here, so you get HF, HI, HCl, and then you have HBr at the end. This is somewhat haphazard. So these both are not correct. Bond dissociation energy, we already know this. HF is higher. I've already discussed this, so this is the correct answer. Moving on. Group oxidation state of halogen family is, well, this is a question which you should answer within a split second, right? Because the configuration is NS2NP5, it needs only one electron to get to NS2NP6, which is the stable one. And as it does that, it gets a -1. So oxidation state -1 is the most common. Moving on, which of the following is not correctly matched? Not correctly matched. Well, fluorine is little yellow, chlorine is greenish yellow. This is all memory based. Bromine is a brown reddish liquid. Iodine is a violet colored solid, right? So this is not correct. It is violet colored. Fourth is the correct answer. Which is the most appropriate reason for noble gases having very low boiling points? See, the reason is that noble gases do not exist as diatomic or homoatomic molecules. They exist as single atoms. And in between single atoms of noble gases, the only forces of attraction are weak van der Waals forces of attraction. Because these forces are weak, the boiling points are obviously less. Because boiling, essentially you are separating the close distant molecules in liquid to large distance in gases. And because forces are weak, you need to give less energy, so boiling point is less. No interatomic forces except weak dispersion forces is the correct answer. Moving on. Which of the following is least polarizable? So least polarizable, if I talk about, will be the one which has least amount of size. Polarizability depends upon the size, and polarizability is directly proportional to size. More is the size, more easily electron cloud can be pulled. So helium is the least polarizable. Which of the following statements are correct? Totally memory based. Natural abundance of, see, argon is the most abundant noble gas. Just remember that. This is true. Noble gases have high positive values of electron gain enthalpy. Yes, normally electron gain enthalpies have to be negative. means energy is released out when you add electron to an atom. But in this case, because they do not want to add an electron, because it has already a fully filled configuration, so energy you need to give to add electrons. So it has to be positive, so true. This preparation of XeF2 requires F2 in excess. No. Actually, if you do X2 in excess, you will get XeF4 or XeF6. This you will get. So you need xenon in excess. So this appears to be false. Right? Complete hydrolysis of all of these gives xenon as product. No, only hydrolysis of XeF2 and XeF4 gives xenon. This gives you XeO3. Memory based, so this is also false. So 1 and 2 are correct. So third is the correct option. Moving on. Which of the following does not exist? To understand this, see, XeF4 does exist, right? We know this. This also exists. This obviously exists, we know that. This does not exist. Just a way to memorize and understand this is that, see, XeO3, right? Here, each oxygen is having 2 bonds to xenon. So if you replace one oxygen, you need to put in 2 monoatomic atoms which can form single bonds. So if you replace one oxygen, you have to add 2 fluorines. So it becomes XeO2F2. Again, if you remove an oxygen, you have to add 2 more fluorines. It becomes XeOF4. Now again, if you want to remove an oxygen, you have to add 2 more fluorines. It becomes XeF6. Now see, most of the stuff is answered from this, but here if you see, XeO3 will never you will get, because O3 means you are you're adding 3 fluorines to XeO3. XeO3 is already stable. Why it will add fluorine? So this is false. So this is the correct answer. Moving on. Which of the following is a colorless explosive solid? Memory based. XeO3. Moving on. Which of the following statements is false? Helium is an inert gas is true. Radon is obtained from decay of radium is true. Xenon is the most reactive among rare gases is true. The most abundant rare gas found in atmosphere is helium. No, it is argon. So this is false. Which of the following statements regarding helium is correct? It is used to produce and sustain powerful superconducting magnets. Memory based. Just see the applications of helium. This is true. It is used as a cryogenic agent for carrying out. Yes, because helium's freezing point is very low. So you can decrease the temperature of helium without freezing it or liquefying it, right? So you can carry out reactions at very low temperature easily. So true. It is used in gas cooled obviously gas cooled, because helium's melting and freezing points are very less. It can be used. Now understand that hydrogen has a proton and an electron. Helium has a proton, 2 protons, neutron, and you have 2 electrons, right? So 1 minute. Yeah, this is fine. Has 1 proton and 1 neutron, and it needs to have 2 protons, correct, sorry. Now because of this, helium has a higher weight and more heavier, right? Atomic number is high, right? You can just understand that hydrogen, helium. So atomic number is 2. So obviously it will be of higher atomic weight, right? Due to which helium is heavier than hydrogen. It is saying it is lighter. So that is incorrect. So this is the correct answer. Moving on. Which is the correct sequence in the following properties? For the correct order, mark true, and for the incorrect order, mark false. So melting point depends upon the force of attraction between the molecules. So obviously, normally melting point should increase based on atomic weight or atomic number. So like this it should be. But because nitrogen has here hydrogen bonding, so it shifts from here to here. So nitrogen, antimony, arsenic and phosphorus. So this appears to be true. In boiling point, the problem is in melting point, the the molecules are close. So these forces of attraction, hydrogen bonding is very strong. In this case, it is not that strong. So it nitrogen, which earlier moved from here till the end, it does not move till end. It just comes in between arsenic and antimony. So this is the boiling point order for the hydrides, right? It is this which is not matching with this. So this becomes false. And finally, bond angle. Ammonia is sp3 hybridized. In these, there is no hybridization, so bond angles are close to 90. This will have the highest, right? sp3, whatever it is, 5 degrees, it should be, but it is less than that. It is around 107 something, right? So it has the highest. So ammonia has the highest, that's correct. Now, when you move from phosphorus, arsenic and antimony, then what happens? Let us see. So size of this atom goes on increasing. As the size increases, the distance between these is increasing, due to which the lone pair which is there here can push them more close by, and due to which the bond angle decreases. Okay, the bond angle decreases, and you can see the bond angle is decreasing. So both of them are, this is true, this is false, and this is true. So TFT, you can see TFT in the first question, right? Now, this can also be answered through another way. See, as you're moving down, the electronegativity of the atom is decreasing. As the electronegativity decreases, what happens? See, normally nitrogen was, let us take phosphorus instead. Phosphorus and arsenic, let me take. So when it is highly electronegative, the electron cloud looks somewhat like this. Okay, there is hydrogen, due to which these electron clouds are very close by, they repel each other, due to which this lone pair is not able to push these electron clouds together and the bond angle opens up. But as you move down, suppose to arsenic, the thickness of the electron cloud here decreases because arsenic is less electronegative. As the thickness decreases, right, now what happens is, if you decrease the thickness, the distance is more between them, right? So this does not mean that it opens up. there will be repulsion between this lone pair. It is better able to repel and push them more closer to each other without inter-electronic repulsions of the electron cloud. That is why the bond angle decreases. So TFT is the correct answer. Moving on. The following are some statements related to, this is the 15th group, hydrides. This we have already done. Reducing property increases, right? So the first statement is true. The bond dissociation energy increases. No. Nitrogen and hydrogen's orbitals energy difference is higher, and that energy difference keeps on increasing as you move to bismuth. And as the energy difference increases, the bond strength decreases, due to which bond dissociation energy decreases. So this is false. The thermal stability of hydrides decreases from this to this. This is true. Bond angle of hydrides decreases from, no. It is, so you have ammonia. As you move down the group, what is happening? The bond strength is decreasing. The thermal stability of hydrides does decrease too. Bond angle of hydrides decreases from, right, this we already done previously, right? It does decrease. So this is also true. So first, third and fourth are true. Second is the correct answer. Which of the following is correct statement about halides of group 16? Halides means H, this is what they're talking about. The stability of halide increases in the order of this. No, the stability decreases. Why? The same reason, because this element belongs to n equals to 2. This n equals to 1. Now, sorry, this n changes. This is n equals to 1. So as you're moving down the group, the n value increases. As the n value increases, the energy difference between the orbitals increases and their overlap becomes less and less effective, due to which the bond strength decreases. Actually, it is showing increasing. So this is false. Tetrahalides have trigonal pyramidal structures in which one of the equatorial position is occupied by two lone pairs of electrons. Okay. Tetrahalides. Actually, in tetrahalides, what will happen? These two lone pairs will not be there, right? Tetrahalides, the number of bonds are 4. The total electrons in this is 6. So only two lone pairs, only one lone pair will be left, right? So it will have only one lone pair left. So what is this? Two lone pairs of electrons. So this is also false. Lone pair itself is 1. All elements except selenium forms, no. All elements except oxygen forms dichlorides and dibromides. It's not selenium, it's oxygen. Dimeric halides of sulfur and selenium undergoes disproportionation. Yes, this is true according to NCERT. So if you erase, let me just erase this. Yeah, slight malfunction. This is proportionate to SCl4 plus S, right? Something like this happens. So this becomes 2 S's. Okay, now this is fine, balanced. Now it's balanced. So disproportionates like this, because here it is -1, Here it is plus 4. So here it is not minus, it is plus 1, plus 4 and 0. So 0 is the lower oxidation state, plus 4 is the higher one, so it is showing disproportionation. So this appears to be true, and fourth is the correct answer. Moving on, what is X and Y in the given? We know that the oxidizing power of halides is in which order? Fluorine, chlorine, bromine and iodine. Right? This is the oxidizing power. Fluorine is that much oxidizing that it oxidizes water also. Right? So here it is minus 2, it changes this to 0. So this X is supposed to be fluorine. Now, halogen, but this kind of a reactivity is shown by chlorine and bromine, where you get hypohalous acids and normal acids. Right? So this has to be, X has to be fluorine, Y has to be chlorine. Right? Pick out the wrong statement, something wrong. Nitrogen has the ability to form p-pi bonds with itself, universally true. Bismuth forms metallic bonds, yes, because bismuth is a metal. Catenation tendency is higher in nitrogen when compared to other elements of this group. This is false. So nitrogen has higher first ionization enthalpy when compared with other elements of the same group. Yes, this is true. So third is the correct answer. Match the following. This requires a little bit of, let us do XeF6, let me do first. You know that the steric number or electron pair formula. The steric number, or I'll say the electron pair formula, is half valence electrons plus monovalent atom plus 1 for each negative charge and minus 1 for each positive charge. Valence electrons here are 8, monovalent atoms are 6. There is no charge, right? There is no charge, right? This comes out to be so we have 7 electron pairs. How many lone pairs? 7 minus 6, you have 1 lone pair. So you have 1 lone pair and 6 bond pairs. Right? This is a special geometry. If you remember, this is a distorted octahedron. Shape, right? Where the lone pair is pointing out from one of the faces, like this. So it is a distorted, and because it's pointing out, it pushes these groups backwards, so it is a distorted octahedron shape. So XeF6 matches with first. XeO3, let us see. Let me just clear this out. Again, using the same formula for electron pairs, half, 8. Oxygen is divalent, so not counted. 4 electron pairs. Electron pairs are 4, right? Lone pairs are electron pairs minus surrounding atoms, 4 minus 3, 1 lone pair. So total it is a trigonal bipyramidal geometry, right? Because 5 are there. Now bipyramidal geometry means where are you gonna keep the lone pair? Where is the lone pair gonna be? We know that For trigonal bipyramidal geometry, lone pair is most stable at this position. Right? One minute. 1, 2, 3, 4, 5 it has become. No, sorry. Yeah. The mistake is the total electron pairs are 4. So it's supposed to be tetrahedral geometry, right? That's what I was thinking. So you have lone pair is 1 and your bond pair is 3. So geometry has to be tetrahedral. So if it is tetrahedral, right? So these 3 can be joined and you will get a trigonal pyramidal structure. Right? So trigonal pyramidal or pyramidal is the third one. So B matches with third. Moving on, XeOF4. Let us clear this out. F4. So half 8 plus 4, 12 by 2, 6 electron pairs. Lone pairs, 6 minus, surrounding atoms are 5, 1 lone pair. So lone pair is 1, bond pair is 5. Looks like an octahedral geometry. The geometry is octahedral. Shape. Right? The double bond O and lone pair are kept at 180 degrees repulsions because they want maximum distance we want from them, so that repulsions are reduced. So this looks like, if you just remove this, square pyramidal, right? It is a square pyramidal geometry. Let us see where it is. Fourth. And finally you have XeF4. Let us do that as well. Half 8. Again you will get 6. Lone pairs will be 6 minus 4, 2 lone pairs, right? So lone pair is 2, bond pair are 4. Again you have an oct geometry. Lone pair repulsion should be minimum, so you have to keep it at 180 degrees. Right? So if you remove the lone pairs, hide them out, this becomes square planar shape. So the square planar is in 2. So 1, 3, 4, 2. 1, 3, 4, 2. 1, 3, 4, 2. First is the correct answer. Right? In case of nitrogen, NCl3 is possible, NCl5 is not. The only reason is because nitrogen has 2s2, 2p, 3 configuration, n equals to 2. And n equals to 2 does not have d orbitals or f orbitals, right? Because L value can be from 0 to n minus 1, right? So NCl5 is not possible due to, but phosphorus can form PCl3 and PCl5 due to availability of d orbitals. So first is the correct answer. XeF2 and XeF6 are separately hydrolyzed. Okay. If XeF2 is hydrolyzed, if I remember, get HF plus oxygen. This is what you will get. But XeF6, if you hydrolyze, at the end you will get XeO3. So XeF2 alone gives O2. None of them will match, right? Neither of them give HF, no. This gives HF. XeF6 gives O2 and XeF2 does not. No, this is also wrong. Both give out O2. No, this is also wrong. So third is the correct. Which of the following is used in the estimation of carbon monoxide? Well, this actually is from, this you can understand from your 11th first chapter of organic chemistry, where you have learned about the quantitative estimation of elements, where in the estimation of oxygen, the last reaction was carbon monoxide reacting with I2O5 forming carbon dioxide and I2. From that knowledge, you can understand that the answer should be I2O5. Okay, remember that from that chapter. Which of the following is used as bleaching agent? ClO2, memory based. Which exists as dimer? C. Here ICl3 exists as dimer of I2Cl6. Like this, right? Which of the following is correct? Again, memory based. OF2 is thermally stable, right? Which of the following is more soluble in water? See, noble gases do not have any kind of forces of attraction except weak van der Waals forces, right? So the only thing you have is you are having weak van der Waals forces, right, or London dispersion forces. Which are directly proportional to what? Number of electrons or atomic number. So atomic number increases in what order? In this order. Right? Radon is an exception, just remove that. So the most soluble is xenon, right? Xenon is the most soluble in water because of high van der Waals forces of attraction. At radon, the size becomes so much high that the distance becomes too much and the forces of attraction are not that strong. So a fine balance is found at xenon. Which of the following has more number of lone pairs? You can calculate that. The one which has least number of monovalent atoms, right? So this has maximum monovalent. This has least monovalent. So when you calculate electron pairs in this, 8 plus 2, 5 you will get here. The lone pairs, electron pairs minus surrounding atoms. What is electron pairs? Here 5 minus 2, 3 lone pairs you are getting. Maximum here only. So third is the correct answer. Moving on to the last question. Yes, we have reached the end of this marathon of solving questions. Which of the following has highest melting point? The one which is solid, right? This is a gas, this is a liquid, this is a gas, this is a gas, sorry, this is a liquid and this is solid. Why? Because the only forces of attraction are van der Waals forces and they are directly proportional to molecular weight or number of highest in iodine, right? So with this, I conclude this session of solving questions, right, of your today's NEET examination, right? Now we will meet again at the time of your next exam, where again I will solve the complete chemistry part of your practice exams. So bye for now from Knowledge Hub at Sri Chaitanya.